The hidden truths of black holes revealed. Black holes, the cosmic giants that have fascinated scientists and the general public alike for decades. Their mysterious nature has sparked endless questions and theories. We'll expose the cutting-edge science that's finally revealing what lurks within. Prepare for a thrilling descent into the most dangerous objects in the universe. Your perception of reality is about to be shattered. Hey, geniuses! Welcome to A Genius with a Twist. Are you ready for today's poll question? What happens when an object crosses the event horizon of a black hole? It gets destroyed instantly. It enters a region where time stops completely. It becomes trapped and cannot escape, even light. It travels to another universe through a wormhole. Drop your guess in the comments. Think you've got it? While we dive into the captivating answer, black holes are some of the most mind-boggling objects in the universe. They're so dense and have such a strong gravitational pull that nothing, not even light, can escape once it gets too close. The surrounding black holes is what happens when you cross the event horizon, the point of no return. Once you're in, there's no getting out. Is it a wormhole that leads to another part of the universe? How black holes affect our understanding of physics? Einstein's theory of general relativity describes gravity as the curvature of spacetime, but it breaks down when it comes to black holes. That's because the gravity is so strong that it creates a point of infinite density and zero volume. It's a mathematical impossibility, and that's what makes black holes so challenging to understand. Moving on to current theories, the most widely accepted one is that black holes have an event horizon, which marks the point of no return. Once you cross it, you're trapped. The gravity is so strong that it warps spacetime in extreme ways, causing strange effects like time dilation and gravitational redshift. That's where things get really weird. According to general relativity, it's a singularity, a point of infinite density and zero volume. But quantum mechanics suggests that space is made up of tiny, indistinguishable units called quantum foam, which can't be squeezed into a single point. Black holes are surrounded by a kind of holographic universe, where information is encoded on the surface of the event horizon. This would mean that the information that falls into a black hole isn't lost, but is instead stored on the surface. Black holes are actually doors to parallel universes, and that information that falls in is transmitted to another dimension. It sounds like science fiction, but it's a possibility that physicists are taking seriously. Subscribe for more themes. What should we talk about next? So we can continuing bring more fascinating topics. Be sure to check out our other content for more exciting adventures in the world of space. Recent research has also shed light on the so-called information paradox. If information that falls into a black hole is destroyed, that would violate the principles of quantum mechanics, which say that information can't be destroyed. The answer could be that black holes are not as black as they seem. They might actually be leaking information back into the universe, but in a way that we can't yet understand. Another theory that's gained traction in recent years is the idea that black holes are not objects in spacetime, but rather objects that warp spacetime itself. This would mean that the laws of physics as we know them break down inside a black hole, and that our current understanding is simply not equipped to handle the extreme gravity and energy densities found there. The more we learn about black holes, the more we realize how much we still don't know. Despite the many theories and discoveries, these cosmic giants remain one of the biggest mysteries of the universe. And that's what makes them so fascinating. The ongoing research into black holes is crucial to our understanding of the universe. And it's only by continuing to explore and question that we'll ever hope to unlock their secrets. The heart of black holes or cosmic giants explore more of the mysteries of space. On dark matter and dark energy, the invisible forces that shape the universe. Black holes have always fascinated scientists and the general public alike, and it's not hard to see why. These cosmic giants are shrouded in mystery, and the more we learn about them, the more we realize how little we actually know. Black holes suck in everything that gets too close. There's something more complex going on. The key problems with understanding black holes is that they're incredibly difficult to study. Since nothing, not even light, can escape once it crosses the event horizon, we can't directly observe what's happening inside. We're forced to rely on theoretical models and indirect observations, which can lead to a lot of uncertainty. This has led to a lot of debates and disagreement within the scientific community about what's really going on inside black holes. Are they regions of spacetime where gravity is so strong that it warps the fabric of reality? Or are they something more exotic, like wormholes or portals to other dimensions? Theories suggest that black holes have an event horizon, which marks the point of no return. Once you cross the event horizon, you're trapped, and there's no escape. At the center of a black hole lies the singularity, a point of infinite density and zero volume, where the laws of physics as we know them break down. But what happens at the singularity is still a mystery, and it's here that quantum mechanics comes into play. If we apply quantum principles to black holes, we start to see some really weird and counterintuitive behavior, like virtual particles and negative energy. The implications of quantum mechanics on our understanding of black holes are huge. If we take into account the holographic principle, which suggests that information is encoded on the surface of a black hole, we start to see black holes as not just objects in spacetime, but as the fabric of spacetime itself. This leads to some really mind-bending ideas, like the idea that black holes could be portals to other universes or dimensions. It also raises questions about the nature of reality and how we perceive the world around us. Research has thrown up some really intriguing insights into the nature of black holes. Some theories suggest that black holes could be surrounded by a kind of firewall that destroys any matter that crosses the event horizon. Others propose that black holes could be fuzzballs, balls of energy that are suspended in spacetime. While these ideas are still highly speculative, they challenge our traditional views of black holes and force us to think about them in new and exciting ways. Black holes are still shrouded in mystery, and there's much we don't understand about these cosmic giants. From quantum mechanics to the holographic principle, there is still so much to explore and discover. But that's what makes them so fascinating, and that's why continued research in astrophysics is so crucial. The black hole has not only transformed scientific understanding but has also captured the imagination of popular culture, solidifying its position as a cornerstone in the study of black holes and astrophysics. This celestial marvel exemplifies the powerful forces of nature and invites profound existential reflections about our place in the cosmos. Lies a black hole exerting an immense gravitational pull, a phenomenon both awe-inspiring and terrifying. Observing such intense gravitational effects challenges our understanding of the universe and reminds us of the vulnerability of life itself. The black hole's ability to warp space and time prompts profound questions about the nature of reality and the fragility of existence. Witnessing light struggle to escape the black hole's edge, the event horizon evokes feelings of insignificance, emphasizing the vastness of the unknown and the limits of human comprehension. One of the most perplexing aspects of black holes is their influence on time. Near a black hole, time slows dramatically, creating a disparity in perception between distant observers and those near the event horizon. This phenomenon forces us to reconsider our understanding of time and reality, inspiring both wonder and existential dread. The black hole becomes a symbol of finality, a point of no return that compels us to reflect on mortality and the urgency of scientific exploration. This system is luminous, resulting from the black hole's interaction with its companion star further adds to its mystique. Material from the star is drawn toward the black hole, forming an accretion disk of superheated gas that emits. This bright emission contrasts sharply with the darkness of the black hole, creating a vivid depiction of destruction and creation. The stark dichotomy serves as a powerful visual metaphor for the dynamic forces at play in the universe. Black holes have yielded groundbreaking insights into black hole behavior. By analyzing variations brightness, researchers can infer the black hole's activity and its consumption rate of the companion star. These studies illuminate the complex physics governing extreme environments and deepen our understanding of how black holes influence their surroundings. The dynamic and violent interactions within the unpredictable and uncontrollable nature of cosmic phenomena, reminding us of the mysteries that still elude human comprehension. The duality of fear and fascination that black holes inspire. It challenges our perceptions of reality, existence, and the universe's vast tapestry. By studying such celestial objects, scientists continue to push the boundaries of knowledge, unveiling the intricate workings of the cosmos. At the same time, the existential reflections prompted by these discoveries remind us of our place in the universe and the urgency to explore its mysteries while we still can. As a beacon of scientific curiosity and existential inquiry, the ongoing exploration of this extraordinary system not only advances our knowledge but also deepens our appreciation for the enigmatic and awe-inspiring forces that shape the universe. Answers 3. It becomes trapped and cannot escape, even light. You're absolutely right. its dramatic interplay of light and shadow, its profound implications for our understanding of time and reality, and its invitation to confront our existential fears make it one of the most captivating phenomena in astrophysics. Isn't it mind-blowing? Let's spread the marvel of the universe far and wide. Next title your choice. Cast your vote in the comments. The surprising truth behind astronaut orange suits. What if we could terraform Mars together? The Genius crew can't wait to hear from you and see you on the next mind-bending adventure. But wait, you didn't think we'd let you leave without a twist, did you? As promised, here's our take on the A Genius with a Twist theme song. Sit back, relax, and let the beats blow your mind. All our fellow Earth watchers, don't forget to subscribe. Hit that thumbs up and turn on the notification bell so you never miss a phenomenon. Stay curious and keep watching.
It's a genius with a twist, where knowledge gets a remix. Brain power boost, no time for tricks. We take the ordinary, the stuff you think you know, flip it upside down, watch the knowledge grow. History's hidden corners to science's grand design. We're uncovering secrets, one line at a time. Think you know about gravity? We'll show you how it bends. Think you mastered time? Prepare for unexpected ends. We're breaking down complex stuff, making it clear and bright. So grab your thinking caps, we're taking flight. A genius with a twist, yeah, that's the name. Education with a bang, it's not the same old game. We're twisting perspectives, turning concepts round. Knowledge explosion, the best out in town. A genius with a twist, can you break the code? Before the video ends, the answer's bestowed. We use analogies, stories, and formats so fresh. No boring lectures, we're serving up knowledge with finesse. From ancient inventions to future tech so bright, we're connecting the dots, shining a different light. While butterflies winging inspires a solar array, or how a simple echo can light up your day. We speak in real science, history too is true, but with a twist of humor, just for you. We show how genius thinking, innovation's bold. Impact every single day, stories to be told. From the smallest microchip to the